Wow, that was crazy loud. Yeah, they were doing a test with the emergency system and the super loud noises. So thanks for coming back still. That was crazy, crazy, crazy. So where we finished off was on 5. And we were trying to just remember about bouncing and crossing. Remember bouncing and crossing? Even powers we bounce, odd powers we cross through. Right? Yeah. So even we bounce, and then invisible one is odd. So invisible 1 is odd. And so odd means that we cross through. Cross through. So that means that x equals 1 is going to be a bounce. And then a cross through for those ones. So then we draw a y-axis as well as an x-axis. So at +1 and -1 and -3. And then our end behavior, we look at the powers and we add those powers. So 2, 1, and 1 is going to be a 4. So we add the powers there, we get to the 4th power. So 2 plus 1 equals 4. So we have positive x to the 4th power is the highest power, the degree. And so that's x, and that's even and positive. And so that means up, up. So we're going to be up and to the right and up and to the left. And then we go to graph it now. And so at -3, we're going to cross through. At -1, we're also going to cross through. But at +1, we're going to bounce. And there we go. So now that we graphed it, we can do the inequality, right? Then we can do the inequality. So it says greater than or equal to 0. So what does greater than or equal to 0 mean? Put this on your note card. So it means all numbers greater than 0, all the y values greater than 0, like 1, 2, 3, positive numbers. And so that's going to be, that means above the y-axis. And then we want their answers are going to be the x-intercepts. So answers include the x-intercepts. So the inequality helps us know if we're above or below the x-axis, and then we look at the x-intercepts where we are above or below. So let's see, we're equal to, so equal to means we get a close dot, close dot, close dot. And that also means brackets. That also means brackets. Okay, so where are we above? Where are we above the x-axis? So we are above the x-axis here, as well as here, as well as here, right? So from -3 and to the left, -3 and to the left, we are above the x-axis, so that's -infinity. So the answer is -infinity to -3 brackets in union with, and then we're also brackets -1 to 1. Oh, but wait, in union with, and then 1 to infinity, because we're also going from 1 to infinity as well. But since it's equal to, we can combine those and don't have to do the union. So we're really going to say in union with -1, including 1 to infinity. And so that's our answer. That's our answer. -infinity to -3. In union with -1 to infinity. So now how to do something like that on the test. Okay, there'll be one of those on the test. Awesome. Okay, so then graphing. I'm going to do it super fast because we already discussed graphing a second ago. So hurry and factor that. Get 2 and 3, middle of the term, good. They're both odd, so that's even, and so that's up, up. The x-intercepts are at -2 and +3. And it's going up, up, and it's crossing. Remember, odd means cross through, odd means cross through, odd means cross through. The y-intercept is at -6 even. Because of this guy right here, because that's the y-intercept. Okay, so this one is a 2, 2, and a 1. So 2, 2 plus 1 adds up to 5. So positive x to the 5th power, positive x to the odd power is down then up. Do you remember end behavior? Put it on your note card, end behavior. So down then up is our end behavior. So down then up is our end behavior. X-intercepts at 1, 2, and 3. And we are bouncing. We are bouncing at 1 and 2, and then we're crossing through at 3. And so we're going down then up. So we have a 1, 2, 3, and we're going down then up. And so at 1, what are we doing at 1? At 1, we're bouncing. And at 2, we're bouncing. And at 3, we're crossing through. There we go. Okay, so this is kind of the weird one where you have to manipulate a single coordinate, an xy coordinate. And so this is for your x values. And this is for your y values. And so our y values, we're going to do exactly what it says. We're just going to minus 5, right? We're just going to minus 5. So we have our 3 comma negative 2, and we're just going to minus 5. So that's going to give us a negative 7. But the 3 is going to be opposite. Right now it's being times. And so what's opposite of times? So opposite of times is division. So we're going to go ahead and take that 3 and we're going to divide. So we're going to go ahead, take that 3, and we're going to divide by 3. And so that gives us a 1. So the answer is 1, negative 7. 1, negative 7. This one is actually on the outside. And so the outside means multiply with the y value. Multiply with the y value. So we have our x value again, which is from this guy. That's our x value. So our x value is 3. And our y value is negative 2. So we're going to take this 3 right here and do the opposite. So we're going to minus 3. That gives us 0. Then we're going to take our negative 2 and we're going to times it. We're going to times it. And so we get a positive 4. So don't forget how to manipulate on the test. Following graph is a transformation of x squared. Write an equation for the function. Okay, so we're going to count from 0, 0. So 0, 0 basically is our x minus h all squared plus our k value and our a value. And so let's see here. So we're going to do x. So our original here is x minus 0 squared plus k, which are k is 0. And now we're going to count from 0, 0. 1, 2, 3. So minus 3, so that's going to be left 3. So that's actually x plus 3. Because the reason why is it's minus is the formula, and then we're doing a left 3. And then we're going to go down. 1, 2, 3, 4. So we're going down 4. And so that's going to be down 4 is just going to be just as it says. So the up or down is just what it says. Positive, positive, negative, negative. But then the left and right is the opposite sign. So our final answer there, let's make sure our slope is right. And then over 1, 2, up 1, 2, 3, 4. Yep, our slope is right. So A is just 1. Okay, so it's going to be x minus left. So what is left? Left is plus, and then minus 4. And there's our answer. Put it all together. Left 4, or left 3, down 4. Okay, let's practice graphing it then with our 5 points. So this one's going to be not left 4 now. Remember, it's opposite. Oh, yeah, opposite. So right 4, up 1. That's the third power, Newbold. Okay, so we're going to go right. 1, 2, 3, 4. No, that's wrong. That's wrong. It's opposite. It's opposite. So opposite is left 4. Opposite is left 4. So 1, 2, 3, 4, and then up 1. Okay, so that is going to be our new origin. Now remember the third root, you guys, the third root, if you do an XY table, so the third root goes 0, 0, 1, 1, 2, 8, negative 1, 1, down 1, and then negative 2, negative 8. Right? So that's the apparent function of x cubed. But now we're going to go ahead and we're going to flip it and we're going to half it. So instead of going like this, instead of going 0, 0, over 1, up 1, and over 2, up 8, instead of taking off like that and down here like that, we're going to flip it. So we're going to end up going this way as well as this way. Okay, so we're going to go, and we're going to half it too. We're going to half it. So what's half of 2? 4. What's half of 1? Half. So now we're going to go left 1, half. And then left 2, up 1, 2, 3, 4. This is going to go right 1, down a half. And then right 2, down 1, 2, 3, 4. And so that's our graph right there. That's our graph right there. So there's our graph. That was supposed to cut through there. Left 2, up 4. Cool. What's the domain and range? Negative infinity, positive infinity, negative infinity, far infinity. Negative infinity to positive infinity, going to the left and going up and down. This one's a little different though. This one's a little different. So this is the left 2 now. So we're going to go left 2 and then down 4. Instead of going over 1, up 1, and over 2, up 4, 1, 2, 3, 4, like we usually do, we're going to have to do the 3. And so the 3 is going to be over, 3 is going to be up 1, 2, 3 over 1. And so the 3 is going to be narrower, narrower. So then we're going to go like that, narrower. Go like that, narrower. And so our domain is still negative infinity, positive infinity. But the range starts at negative 4. And then from there, it takes off to infinity. So then we'll be bracket, negative 4, upwards to infinity. Nice. Whoa, fence problem. We'll see if it's on there this year. I don't know. Be ready for it just in case. Yeah, fence problem. Let's see. So 1,500 feet. And we have 1, 2, 3 W's and 2 lengths. No, 4 W's. 1, 2, 3, 4 W's and 2 lengths. So 4W plus 2 lengths is equal to 1,500. Solve for L. So we're going to minus 4W to the other side. Minus 4W to the other side. And then we'll divide by 2. Divide by 2, divide by 2. So we get our length is equal to 750 minus 2W. So that is our length of our equation. Check. To find the function anybody represent the area. So area is just equal to length times width. However, now to be able to determine the maximum area, we need both of those together. And so we're going to go and combine those now that we solved for L. And so wherever we see an L, we're going to plug it in. So area is equal to, instead of L, you're going to plug in 7,500. That's wrong. That's wrong. It's 750, new boat. Sorry, sorry. So half of 1,500. Half of 1,500 is 750. Okay, and then minus 2W. And then times W. Way-o. Cool. So now we're going to go ahead and figure out where this maximization is at the very, very top. We start off at 0 and then go all the way to some distance here. And so where's our 0? Our 0 comes from this factor, W equals 0. Set your factors equal to 0. And then this one will also set equal to 0. And so we'll go ahead and minus 750 to the other side. And then we'll divide by negative 2. divided by -2. So what is 750 divided by -2? Right? My calculator is broken right now, I think. I think I need to open it or something. There we go. Okay, so negative divided by negative is a positive. Half of 700 is a 350, so 25 more, 375. Yeah, 375. So our width is equal to 375, right? That's our other one. That's our other one, 375. So that's going right here. And so that is not our maximum width, but it's going to get us there, right? So from 0, very, very top, to 375. At 375, our width, our length is nothing, right? It's at the x-axis. But as we go halfway, half of 375 at the very top, that's going to be our max width. So we take 375 right here, and we divide it in half. And so 375 divided by 2 is 187.5. Nice, nice. So then we got to find the y value, and that's the maximum area. So we got our maximum width. So our max width is going to give us the biggest area possible, 187.5. Now we just need to find the y value. So we need to find the y value. That's the max area. Well, how do we find that? Well, algebraically, we can just plug it back into the original equation. Let's just plug it in. So the max area now, max area is going to be equal to 750 minus 2 times RW, and then times again RW. So what's our W again? So our W is 187.5. So wherever we see a W, we're going to plug in 187.5 and 187.5, and that's going to give us our max area. So parenthesis 750 minus 2 times 187.5, close parenthesis, times 187.5, and that's going to give us our max area, 70,312.5. That's really big. Is that feet? What is that? Yeah, that's feet. That's feet. So that's going to be 70,312. Yay, we found our max area. So we found our max area there, found our max area, found our max width, and now we just need to find the length. Well, how do we find the length? Well, we have a formula for that, remember? Area is equal to length times width. And the width is 187.5, the length we're trying to solve for, and the area is 70,312.5. And so if we just divide the 187.5 over to the other side, that'll give us the length. So we take that area now and divide by 187.5, and that'll give us our max length, which is 375. Way-o. 375. Way-o. So that's the length. That's the length. It's 375 feet. So now we have the length, we have the width, and we have the max area. Woo! That took a while. That took a while. So that was good though that we got that one done. So just one more video now. Just one more video. We got this. We got this. So thanks for watching. So next we're going to go to our, is that our last page? Oh, no, Newbold, another one. Oh man, you better get going, Newbold. We'll include this last one just to keep it going there. No, you're burnt out. Okay. We'll do the next video. Thanks for watching. See you in a second. Bye for now.